Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we talked about the intuitive difference between PDF and CDF. So in this video, let's test whether you really understood the difference and let's see if you can spot those common mistakes that are made in either statistics or econometric courses when you work with the PDF or the CDF. Let's always refer to the nice bell-shaped curve that we have seen in the previous videos as well. Keep in mind, the shape is given to us by the PDF, so the probability density function. Consider also x a random variable, and let's answer the following questions based on this PDF and the existence of this x random variable. The first question is, what's the probability that x is equal to 1? Well done for giving it a thought. Now, the answer here is 0. Keep in mind, even though at point 1 in here, you have a certain height. Okay, so imagine that I would have also here another axis. And in this axis, I have basically probability numbers and so on. So even though there is a certain height associated with number 1, probability is 0 at exactly 1 point. There is no area there. A point has no width. No width means no area, no probability. So let's move to the second question then. What's the probability that x is bigger than 0 or smaller than 1? Well, now you should be able to see the difference. Well done for giving it a thought. And if your answer was, well, now we have an area, so it's the entire area under the curve between 0 and 1. So in this case, the pink shaded area that I just did in here. Okay? So that pink shaded area. Keep in mind, the PDF tells us how dense probability is. The area tells us how much probability there is. So if we were to give the answer to question 2, but using the CDF definition and what we know about the CDF, how would our answer look like? Try to give it a thought for a second. Well done for giving it a try. So the CDF at point 1, so we would have a probability that x is smaller or equal to 1. Let's call this f of 1. Then at 0, we would have f of 0, which means that's the probability of us seeing something smaller or equal to 0. So in terms of answering through the CDF, the probability of us looking at an x that is between 0 and 1 is literally the difference between the CDFs at the 2 points. Okay? So keep in mind, the CDF just keeps running totals of areas. So how exactly does this show graphically? So again, we have the bell-shaped curve. Not so bell-shaped. And when we said for point 0, in terms of the CDF, I was looking at the entire area over here. And for 1, I am looking at the entire area on the left of 1. So that means, what is the difference between the two? Well, it's the only area covered by the purple line, or the one that's in the pink area, exactly the same answer that we gave in terms of areas under the PDF. Okay. It's just the computation in here was slightly different in order to use that cumulative property of the CDF. Let's check one more point before we conclude this video. True or false? A higher PDF value always means a higher probability. If your answer to this was false, then you did well. Keep in mind, probability does depend on the area, not the height. Okay? So probability, area, not height. That's why in the previous video, we said that we could have areas that are quite narrow and tall, have the same probability as areas that are quite large overall, although not so tall. In fact, a tall, narrow region can also have less probability than a short, wide region. Overall, the key takeaways from this video should always be the same as the ones we saw in the previous video. PDF will show you the shape, while the CDF will show you the accumulated probability. If you confuse height with area, inference won't make sense for you. So make sure you have this concept all down. Thank you for following this video, and I'll see you in the next one.